In today's video, I'll be going to go through Monte Carlo method or simulation as they call it, and give you a short introduction into how it works and how we're going to use it to solve a particular problem. So what is a Monte Carlo simulation? It is an algorithm that uses randomness or random sampling to obtain the numerical result that you want. You might be thinking, how does randomness allows us to obtain a deterministic result? Well, it works on the basis of the strong law of large numbers. And the proof is as follows. We start off with Chebyshev inequality, that the probability that your random variable minus away the population distribution mean, that absolute value is larger than a constant, is less than the variance over that constant squared. And so now, when you apply this random variable to become the mean, and you take that as the new random variable, so x1 plus all the way to xn over n is now our random variable. This random variable minus away mu, and this mu is exactly the same mu as this, because you can just work out the expectation for this mean random variable. That absolute value over an error is less than or equals to sigma squared, which is the variance of the original distribution, over now n squared times error squared. So you can see that the right hand side over here is a function in terms of n, and so as n approaches infinity, this right hand side goes to 0, and so by the squeeze theorem, this left hand side will also approach 0, since probability is always larger than 0, and thus the average approaches the actual population mean that we want. So this is actually how does the Monte Carlo simulation allows us to calculate the mean that we want by taking an average value after performing the trials many times, and the more trials that we perform, the better the approximation. So this is an overview on how to set up the Monte Carlo simulation. So your first idea is always just generate a bunch of random inputs from the distribution. Then you perform your experiment multiple times, and then you just take the average result at the end. An example will be now shown to better understand what I mean. So let's look at it. So now we will use Python to help us with our simulation. So our first step is to generate a random inputs based on the distribution. So our problem that we want is find the probability of success of obtaining heads when you toss a coin multiple times. Based on mathematics, the theory tells us it will be 0.5, and so we will check whether the simulation agrees. So let's import random and import matplotlib to plot our graphs and generate random results later on. We will now define our function to flip a coin, which is just a random integer from either 0 or 1, and where 0 represents tails and 1 represents heads. So you can see, we'll run this function, we'll run the coin flip, is 0, so the first value will be tails in this case. Now this shows how our function works. Now we create an empty list to store our probability values, and then we define the simulation, and the results equals to 0 at the start since there is no heads or tails. Then for I in range n, you do your flip underscore result equals to coin flip. So this is the function that you generate. Your result now equals to your original results plus your flip result. So it's either 0 or 1, you can just determine. And then your probability is just results over I plus 1. So this probability value is your probability of success after maybe 2 trials, 3 trials, n trials. So it continuously runs. Then you append every time to your list to calculate how much is your probability value. These next few lines are to plot the graph and then when you plot the graph, you return, after plotting the graph, you just return the results over n, and so this result will be your final number of successes, and then you just divide it by n, which is the number of trials. So let's just see an example. So you run the function, then you do 100 simulations, and so you can see 0 is at the start here, cause at the top your coin flip was 0. Then it may have got heads multiple times, so the probability increased very high. Then it got a few tails, it goes back down, and then it hovers around, and then you can see that it slowly increases back up. And so our final answer is around 0.42. Not the best, but you can see that from the graph trend, it feels like in the long run it will approach the value 0.5. And for now it's 0.42, which is already close to 0.5. And it is basically because we only run it for 100 times. If we were to run it for maybe 1,000 times, so 1,000 will just take a longer amount of computational time, and so we'll just let it run first. And when it's done, you see that it flips up and down, and then after a while it approaches this red line, which we already plotted it as to be the 0.5 line, and it gets very close. And so our answer is even closer to 0.5 now that we have run the simulation more times. And this is basically it for understanding what is a Monte Carlo simulation. It just applies the law of strong numbers, the strong law of large numbers to an experiment, and then you just run it using a computer and it will approach the value that you want. And by now, the hardest part of performing a simulation is not really the code, but basically how are you going to formulate the problem you want into such a probabilistic question in which you can then use the strong law of large numbers to your advantage. And so I'll be sharing this code with you so that you can see it for yourself and apply it to other forms which uses similar techniques. But for harder problems, you have to discover how to formulate the simulation yourself. Thank you for listening, and that's the end of the video. I hope you have liked the video, and feel free to like, share and subscribe, and leave any comments down below. Thank you.